Hello, my name is Ashis and I am going to present our paper named Teledrive, a multi-master hybrid mobile telerobotics system with federated avatar control. So in my presentation I am going to cover these topics. So first, starting with the introduction. So Teledrive is a mobile telerobotics system where multiple remote masters can join a telepresence session, whereas master will get the avatar control in a federated manner. Avatar is the robot here, whereas each master will get exclusive avatar control at a time. So I am going to explain this in a very simplistic telemedicine use case, whereas one remote doctor want to inspect his patient from different geographic location. So patient has admitted in a local hospital, and local hospital attendant is also there. So and the robot is now in the control room of the hospital, and she knows where the patient cabin is and where the control room is. So she also joined the session, and she takes the control of the robot first, and then she navigate the robot towards the patient cabin, and after reaching there she relinquishes her control, and doctor will take the control of the robot and then started inspecting the patient. So for this we have defined our hybrid topology model, whereas a cloud-based architecture is also there, as well as on-demand P2P for federated and exclusive avatar control is also there. So we have defined a custom application layer message format, and at last we have evaluated our performance in terms of latency with cloud-based system. So coming to the motivation, so we built our solution using WebRTC APIs. So WebRTC in current days is a very dominant technology in various telerobotics applications. So it allows to establish a P2P connection between master and avatar. So P2P connection offers a SRTP based media channel and SCTP based data channels for control data exchanges. The media channels is responsible for the multimedia communication. So if the master and the avatar pair are behind restrictive NAT, so then they will fail to establish a direct P2P connection. At that time, WebRTC has a provision to establish a P2P channel through a TAN server. So when the number of master is more than 1, at that time we term this as a multi-party WebRTC. So two popular topology is there in the SOA. First is the mesh topology, and the second one is the star topology. So in mesh topology, suppose there are n pairs, so that each pair of that n pairs will establish one-to-one connection with every n-1 pairs. So if the n started increasing, at that time it will create a total n factorial number of connection, which will not be scalable at all. So star topology is a better option for that. So it can be MCU based or a SFU based. So it has a central node which will be situated in the cloud, and every topic including audio, video and the control data will be exchanged through that central node. So an extra delay will be added when the traffic will go through the central node, but the robot control data may demand a more real-time scenario. So for this we are proposing our Teledrive as a hybrid topology, so where the cloud architecture is still there, and along with that we are proposing an on-demand P2P channel which will help to exchange the delay critical control data. So in the next slide, this slide we will describe our hybrid Teledrive architecture. So as you can see, the signaling server is there to exchange the signaling data, and the broadcaster node is the central node of the cloud. So both the signaling server and the broadcaster is in the cloud. So broadcaster has two resource, one is state register, another one is media manager. So and first every master peer and avatar will establish a connection with the broadcaster. As a whole, it will make a start topology, and the media manager, it will receive individual audio video stream from the avatar peer and each master peer, and then it will make this audio video stream as a composite one, and it will send to every other peer. And along with that, one P2P connection can be established here. So it is a on-demand P2P connection. When any master I want to connect or want to take the control of the robot. So in the next slide we will describe how the state register maintained its states. So this is the transition diagram of the states. So here we have defined a 3 state. So state 0, state 1 and state 2. State 0 means when robot is not at all connected in the broadcasting session, and then when it is joined in the session, so at that time, so if robot is free, that is it is robot control is not acquired by any master, so at that time it is defined as state 1, and if some ith master takes the control of the robot, then it will transit to the state 2. So in the next slide, here we are going to describe our protocol of our hybrid topology in terms of timing diagram. So this is the initial timing diagram, initial protocol. So whereas any PRI can be a master or a avatar peer. So when it try to establish a connection request, that is he wants to join in the session, so it will send a connection request along with its peer type. So peer type M means it is a master and A means it is a avatar, and broadcaster will send the similar connection request to the signaling server, and upon receiving these two, signaling server will send a connection request to initiate the session to the broadcaster, and then broadcaster will send an offer message to the PRI via signaling server, and again it will receive an answer from that peer, and then they will exchange their ICE candidate, and after that the connection will be established between that peer and the broadcaster, and audio video started transmitting in both way. So after the session, if that PRI want to disconnect from the session, it will send a disconnect request, and which will be conveyed to the broadcaster via signaling server. Then when the master I, master K and avatar have already joined in the session, at that time if master I wants to take the control of the robot, then it will send P2P connection request as described here, and it will be conveyed to the broadcaster via signaling server, and upon receiving that request, broadcaster will check its state, the current robot state in the state register, and if it is state 1, that is the robot is joined in the session and it is free, so at that time broadcaster will send a request acceptance, and it will send a connection initiation request to the avatar, and upon receiving that initiation request, avatar will send a P2P offer to that master, and it will get a answer from the that master, and then they will exchange their ICE candidate and the connection will be established. So and after that, that master will send a establishment status, that as a message like the connection is a P2P connection is established, and it will be received by the broadcaster, and avatar will send the same, and again when broadcaster will receive these two confirmation message about the connection establishment, then it will transit its state to the state 2 from state 1, and it will notify to every master about its states, about its state. So in the next diagram, so the P2P is already established before, and so now after controlling the robot, if that master want to disconnect, then it will send a P2P disconnection request, and upon receiving that, broadcaster will convey that to the avatar, and then broadcaster will again update his state to state 2 to state 1, and it will again notify to every master peer. And this diagram will describe us the federated and exclusive control of the robot or the avatar. So this is when robot is not joined in the ongoing broadcast session, or it has joined but already acquired by some other master. At that time, if some other master send a P2P connection request, then upon receiving that request, broadcaster will check its state, and it will, if it is state 0 or state 2, then it will send a rejection along with the robot's current status. Here we have also defined our custom application layer message format for this topology. So where the we have used a JSON format. So all these parameters of the JSON format described in the table in the left hand side. So the connection type, it consumes 1 bit information, where 0 means the connection is for the broadcasting session, and 1 means the connection for the P2P for avatar control. So room ID is a unique room meeting session ID for that current session. Then message type consumes 3 bit information, and based on these message types, a type specific message format is also defined in the right hand side figure. So for our experimentation, we used our broadcaster and the signaling server. We have hosted it these two on AWS cloud, and we have deployed our own TAN server using CoTAN. We have designed a browser UI console for the active master and the active avatar also. So as you can see, the active master can see the avatar video feed as well as the video feed from other masters, and same as the avatar also, it can see all the masters video. And along with that, the active master has some the control button to control the robot for manual maneuvering. So here we compare our the latency of our hybrid Teledrive with a cloud based only model. So when a master press a key, suppose the F button, so the command will be received by the avatar, and upon receiving that, it will send a F acknowledgement, F_ACK, to the master, and when the master will receive it, it records it that timestamp as T2, and T1 will be recorded when master press that command. So, and we have measured our latency as RTT, where it will be calculated as T2 minus T1, and we took the data in different time segment of a day, in the morning, in the afternoon, in the evening, and in the night, and we have and it has been it is clear that our Teledrive hybrid has shown the better performance than the only cloud based model. And along with that, we have plotted another plot where we have compared our hybrid Teledrive when the P2P is the direct P2P, along with it is the P2P through TAN. So at that time also we have seen the direct P2P has shown much better result. And on the visual aspect, we have done an experiment where initially the avatar is facing a blue bottle, and master can see the blue bottle. So then master press an L command, and he started rotating towards left, and when it sees the red bottle, at that time master press a stop button. So that too, when the master press the L command, so at that time T1 timestamp is recorded and T2 recorded when master press the stop button. So by differentiating these two from in T2 minus T1, we have calculated our response time. So, and we have compared this for our hybrid Teledrive model and only cloud based model, and as we can see here also hybrid Teledrive has shown better performance. So coming to the conclusion, so Teledrive consists of a unique telerobotics communication architecture with custom signaling protocol built using WebRTC APIs. This hybrid topology allows multiple human users to join a conferencing session along with the federated control mechanism for Telerobot. It provides an integrated platform for audio-video based telepresence system along with an on-demand exclusive avatar control for maneuvering the Telerobot. And this hybrid architecture has shown better performance compared to the only cloud-centric architecture, as we have seen just in the previous slide. So we have a plan to extend this hybrid topology for multi-robot system. So now with this I am concluding my presentations. So thank you.